All right, guys, so today we're talking about function notation. In the notes here, you'll see it starts off by saying f of x means function of x. It does not mean f times x. And where you'll see this a lot of times is we get really used to writing things like y equals 3x. We like this format because it's quick, it's short, it's easy. And we've learned that what this means is if I take a number for x and I plug it in right here, I'm going to get a value for y, and that's going to equal a spot on the graph. All that old 9th grade stuff, right? Well, in function notation, it says on the next line that the y is replaced with f of x. So it's exactly like saying y equals 3x, but instead we are saying there's a function of x that equals 3x. And the reason we like this form is you can see a little bit easier what value is going in and what value is coming out. So when I say f of x equals 3x, I can say f of 4. And what that means is when I change the x value to a 4, I get this. I get 3 times 4, which equals 12. So when I put a 4 in, I get a 12 out. That's what function notation shows me. There's another example right here. If my function is 2x plus 8, if f of x equals 2x plus 8, then f of 5 means that everywhere there's an x, I replace it with the number 5. So over here next to the 2 was an x, I replace it right here with a 5, and I get 2 times 5 plus 8. All right, so a couple of examples how you'll see this used. Almost every ACT test I could find has a problem that looks exactly like example number 1 and 2 right here. It gives you a function and it names it. So for this first one, for number 1, it says my function g of x is equal to the absolute value 7 minus x. And then it wants me to find these. First, it wants me to find g of 10. And what that means is everywhere I see an x in the function g, that's the key here. Anytime I see the value or the letter x in the function g, I replace it with 10. So g of 10 equals the absolute value of 7 minus 10, which equals the absolute value of negative 3. And if you go back and remember, absolute value means how far is it from 0, and that becomes a positive 3. Okay, g of 0 means use the g function and plug in 0 instead of x. So I get absolute value of 7 minus 0, which equals the absolute value of 7, which is just 7. G of negative 8. In the g function, I'm going to replace x with negative 8. So I get absolute value bar 7 minus a negative 8. Now, anytime I'm substituting a negative, I'm usually really careful to put it in parentheses to make sure that if I type it in my calculator or I get working really fast, I don't forget that there's a negative number there. Because 7 minus negative 8 actually means 7 plus 8. And my calculator will know that if I put in the parentheses correctly. So 7 plus 8 equals the absolute value of 15. The absolute value of 15 is just 15. All right, example number 2. If f of x equals 2x squared plus 1, find f of 5, f of negative 3, f of n plus 1. I love this question. So the first thing I'm going to do is I'm going to use the f function, and I'm going to plug 5 in for the x. So I get f of 5 equals 2 times 5 squared plus 1. Now this is one, I would probably never write it that way. I would write it 2 parenthesis 5 squared plus 1. And just like with a negative, when your variable is right next to a number, if sometimes you forget that you're supposed to multiply and you'll just write 2 5, and then you've got 25 instead of 2 times 5 being squared. So parentheses help when you're substituting. Order of operations, 5 squared goes first. So you get 2 times 25 plus 1, which is 51, right? F of -3. This is one we're going to be really careful of because I'm going to take my f function and I'm going to replace that x with a -3. And I'm definitely not going to forget the parentheses on this one. This part I can just type right in my calculator. When I put the parentheses in the right place, I can plug it right in my calculator and I end up with the answer 19. If I don't put in the parentheses on this one, my answer is going to come out to be something else. It's going to come out to be -17, which is wrong. So we got to be careful with parentheses. C says to take the function and plug in n plus 1 everywhere you see an x. I love this. So I have a 2, and then I'm going to put this parenthesis, and instead of an x, I'm putting in n plus 1 squared plus 1. Now, we haven't really taught you what to do with this part, what to do with a parenthesis that's being squared yet. So I'm going to leave that one just like it is for now until we get a little bit further into our lessons and you know what to do. But that's what it looks like. Instead of an x, you're replacing x with this entire n plus 1, and that's what it would look like in function notation. So one of the purposes of function notation is to help us work with multiple equations, okay? A lot of times you're not just dealing with one function, you're dealing with multiple functions, and having them labeled as f and g and h and I and a or whatever else can help kind of keep track of what number you're putting into what function. So right here we've got 3 functions, f, g, and h. So I've got f of x is 2x minus 5, g is x squared plus x, h is 3x. And then it wants me to evaluate different things. This one, first one wants me to use the function h and plug in -4. So I find the h function, which is over here, and I replace the x with -4. So h of -4 equals 3 parenthesis -4. Type that in my calculator and I get -12. Okay. The second one wants me to use the function g and plug in a 1. So I'm going to use the g function. G of 1 equals 1 squared plus 1. Again, because I'm using a square, that's another good time to use parentheses. Really, most of the time is a good time to use parentheses, but we're hitting some right here for sure. So 1 squared plus 1, plug it in your calculator, you get 2. Okay? And then the last one, function f, plug in n. So I'm going to go up here to my f function, and anywhere I see an x, I'm going to replace it with the letter n, and I don't get a number answer because I replaced it with a different letter, and I can't get a number answer. I'm stuck at 2n minus 5. All right, couple more examples. For the function f of x equals 2x minus 5, find the input for each output. So sometimes when we have this function f of x, instead of telling us what to plug in for the x value, it will tell us what it wants our function to end up equaling. So in this case, instead of f of x, it wants my function to equal 7. So this, whoops, wrong button there. Instead of this f of x right here, it wants that to end up equaling 7. So I would write 7 equals 2x minus 5. And what I'm looking for is the x value that when I plug it in right, that's not the right button. When I plug in something right here for x, I'm going to end up with 7 as my final answer. So 2x minus 7 equals 2x minus 5. I just want to figure out what x is. So I do my railroad tracks. I add 5 over here, add 5 here. 12 equals 2x, divide by 2, and x equals 6. So that tells me that when I plug 6 into this function, f of 6 is going to equal, it should equal 7, right? And if I try that, 2 parentheses 6 minus 5 becomes 12 minus 5, which equals 7, just like I wanted it to. Okay, find x if f of x equals -11. So same idea, it tells me what it wants my function to end up as. I'm looking for the x value that's going to make that happen. So I'm going to take -11 and I'm going to replace it with, I'm going to plug it in, substitute it for all of the f of x, the entire thing, not just the x part. So -11 equals 2x minus 5. I do my railroad tracks, I add 5 to both sides. I get -6 equals 2x, divide by 2, and x equals -3. Okay, so you're going to see some story problems. These are also very popular on the ACT because it wants you to be able, well, I guess it wants to test if you're able to differentiate between what we just did. It will give you a function, and it wants to know if you know when to plug numbers in for the x and when to plug numbers in for the entire function to replace the f of x. It wants to check that. So it gives me a story problem. Will just joined a poetry writing group in town that meets once a week. The number of poems that Will has written after a certain number of meetings can be represented by this function, where P represents the number of meetings that Will has attended. That's something that we don't want to lose track of. P is the number of meetings. That's a good thing to make a note of. So part A says, using this function, how many poems has Will written after 7 classes or 7 meetings? Okay, classes, meetings, it's talking about the same thing. So what this is telling me is either P is equal to 7, or it wants me to know when f of P is equal to 7. And what if I read it again, it tells me that Will has written after 7 classes. So the 7, the value 7, goes with the number of classes or the number of meetings, which is P. So the 7 isn't my f of P. The 7 is my P value. So I know that in this case, P equals 7. So I can plug that into my function. F of 7 equals 2 times 7 plus 6, which equals 14 plus 6, which equals 20. So Will have written 20 poems after 7 class meetings. Okay, part B says, using the same function, how many classes will it take for Will to write 31 poems? So in this one, the number of classes is what I'm looking for. I'm looking for P. I don't know what it is, but I do know that I want, whatever P value is, I want to end up with 31 poems. So in this problem, I want f of P to equal 31. So I go back to my function up here, and I want f of P to be 31, and that's going to equal 2 multiplied by some number of classes. I don't know what number yet. Add 6, railroad track, minus 6 from both sides, and I get 25 equals 2P. If I divide by 2, did I write my function correctly? Yeah, okay. So if I divide by 2, I end up with P equals 12.5. So what that means is I need a little bit more than 12 classes to write 31 poems. So I don't want my answer to be 12.5. We talked about our answers making sense. I also don't want to round down to 12 classes, because in 12 classes, I'm not going to have 31 poems. I'm going to have less than that. So I want this to round up to 13 classes, just using some common sense with that answer. Okay? All right, turn your page over. Practice problems are on the back. Numbers 1, 2, and 3, you're plugging in a bunch of things to a function. Be careful of the C parts. I love these questions because you're plugging in weird things for x's instead of just a number. You're plugging in something else. Simplify things as much as you can, especially on that part C. You won't always end up with a number answer because you're going to have letters stuck in your answers on those ones. 7 and number 10, I know those don't go in order. Don't worry about it. 7 and number 10 are problems where it gives you the final answer and it wants you to find the x, just like we did on the examples. And then the last couple of questions, I know they're not numbered. You can call them whatever you want. We can call this number 11. We can call this number 28. And we will call this number 42. Then you can tell everyone you did 42 math problems on your homework. I don't care what you call them. Call them whatever you want. But those 3 questions look like the story problem that we just did on the notes. So give these a try. If you have any questions, come find me and I'll help you with these problems.